Hello dear student, welcome in the online lecture series. I am Dr. Balasaheb Pagar, working as a associate professor in chemistry, Srimati Vimlaben Khimji, Tejukaya, Arts, Commerce and Science College, Devlali Camp. Dear student, in the previous lecture we discussed about the hydrocarbons. So what is meant by hydrocarbon? Hydrocarbons divided into a number different types means the classification of hydrocarbons. So what is meant by hydrocarbon? Hydrocarbon is nothing but the compounds which is made by using only carbon and hydrogen. Means those compounds that having only a carbon and hydrogen atoms. For example, alkanes, alkenes, alkynes, aromatic hydrocarbons. So all these points discussed in the previous lecture. So hydrocarbons include the alkane and alkynes or alkynes. So in the previous lecture we discussed about the alkenes. So what are alkenes? Alkenes nothing but the unsaturated hydrocarbon containing a carbon-carbon double bond, means CnH2n. So this is the general formula of alkene. So in this chapter we discuss about the nomenclature of alkenes as well as the preparation, industrial preparation and preparation of the alkene, and also the reactions of the alkene. So alkene that undergo the addition reaction because there is a presence of carbon-carbon double bond. So all these points discussed in the previous lecture. So today we discuss about the alkyl halides. So what is meant by alkyl halides? So the introduction means this topic include a different types of the points, means introduction to the alkyl halides, then IUPAC nomenclature of the alkyl halides, tribal name as well as the IUPAC name. Then the alkyl halides undergo different types of the reactions like SN1 reaction, SN2 reaction. So this also discussed in this lecture. So student must be learn about the reactions of the alkyl halides. Means alkyl halide that having a carbon and the halogen. We know the halogen atoms are more electronegative. So because of the more electronegative, on the halogen there is a delta negative charge and on the carbon there is a delta positive charge. So the alkyl halides, after breaking this bond there is formation of a carbocation, means in the reaction alkyl halides gives the carbocation, and different types of the reaction means electron rich species when react with a alkyl halides there is a displacement reaction, means the substitution reaction takes place. So alkyl halides undergoes a different types of the reaction. So today's lecture we discuss about the introduction, nomenclature, then the preparation of the alkyl halides. So student must be learn following points. Student must be draw the different types of the structures of the alkyl halide. Then name the alkyl halides according to the common name system or according to the IUPAC nomenclature system. So student must be explain or learn the synthesis of the alkyl halide, can write the mechanism like SN1 reaction mechanism or SN2 reaction mechanism. So substitution, nucleophilic, unimolecular or bimolecular or intramolecular reaction, means alkyl halides undergo the substitution reactions. Student must be learn about the reactions of the alkyl halides. So alkyl halides undergoes different types of the reaction. So most important reaction, that is a substitution reaction, and another reaction, that is a elimination reaction, because there is a halogens are the good living groups. So undergo in presence of a alcoholic base, undergo elimination reaction, and there is formation of a unsaturated products. So student must be learn the reactions of the alkyl halides. Alkyl halides are the organic compound. So what are if we see the structure of alkyl halide, that is a RX. R is the carbon, means that may be alkanes, means hydrocarbon, and X is the halogen. So name if we look in the formula Rx, So according to the formula, simple definition of the alkyl halide is the halogen derivatives of the alkane. Means those compound contain halogen in the compound, that is known as a alkyl halide. Halogen derivatives of the alkane. So alkanes, the R group may be aromatic, R group may be aliphatic. If the R group is aliphatic, then name of the compound is the haloalkanes. And if the halogen which is bonded to the aromatic ring, then name of that compound is the haloarenes. Means alkyl halides attached with a aliphatic chain, or the halogen atom attached with a aromatic hydrocarbon. So according to this, name of this compound is haloalkanes or the haloarenes. Well-known example of the aryl halides, that is a chloroquine. In the chloroquine molecule, there is a chlorine which is present in the aromatic ring. So this is the example of haloarenes. So chloroquine, well-known example, well-known drug we use on the malaria and the different types of the disease. Classification of the halogen derivatives. So classification of alkyl halides, that is two types of classification. First type, that is it depends on a number of halogen atoms which is present in the molecule, and another type of the classification which is depends upon the nature of R group, means Rx. First classification which is depends upon the number of halogen atoms present in the molecule, and second classification which is depends upon the nature of R group, means nature of R group may be primary, secondary or tertiary. So depending the first classification which is depends upon the number of halogen atoms which is present in the molecule. So halogen derivatives which is divided into two groups, monohalogen derivatives and the polyhalogen derivatives. Monohalogen derivative, in the name there is a mono. Mono means only one halogen atom which is present in the molecule, that is known as a monohalogen derivatives. Polyhalogen derivatives means more than one halogen atom which is present in the molecule, that is known as a polyhalogen derivatives. And the polyhalogen derivatives which is divided into again a three types: dihalogen derivatives, trihalogen derivatives and the tetrahalogen derivative. Dihalogen means the two halogen atoms which is present in the molecule. Trihalogen means the three, and tetra means the four halogen atoms which is present in the molecule. So this classification is depends upon the number of halogen atoms present in the molecule. Another classification which is depends upon the nature of R group, means the R group may be different, means the primary carbon, secondary carbon or the tertiary carbon, means halogen atom which is attached to the primary, secondary or tertiary carbon, means the second classification which is depends upon the nature of R group. Primary alkyl halides means an alkyl halide in which the halogen atom, means chlorine, fluorine, bromine or iodine, is bonded to the primary carbon atom. Primary carbon atom means that carbon atom attached with another only one carbon atom, that is known as a primary carbon atom. So if that carbon attached with halogen, so that is known as a primary alkyl halides. And if the halogen which is attached to the secondary carbon atom, that is known as a secondary alkyl halide. And if the halogen which is attached to the tertiary carbon atom, that is known as a tertiary alkyl halide. Primary carbon means that carbon attached with only one another carbon. Secondary means that carbon attached with another two carbon atoms, and tertiary means that carbon attached with another three carbon atoms. Okay, so this classification depends upon the nature of R group. Then nomenclature of the alkyl halides. So common name system, and the another system is IPC nomenclature system. In this system, in the common name system, the nomenclature of the name of the alkyl group and the name of the halogen atom. Means this system is very simple, which is depends upon the name of the alkyl part and the name of the halogen atom. For example, the first CH3I means the CH3 means the methyl, name of this CH group is methyl, and iodine, so methyl iodide. Then another example, CH3, CH2, CH3. So here the bromine atom attached with a middle carbon, and the name of this group R group is the isopropyl group, and hence common name of this compound is the isopropyl bromide. And the another example, there is a 4 carbon atoms and the halogen which is attached to the carbon number 2nd. So name of this alkyl group is the secondary butyl group. So secondary butyl chloride. Name of the common name of this compound is secondary butyl chloride. In order to name organic compounds, we must first memorize few basic things. Means for example, halogen atom which is attached to the alkane. So first part is the to select the continuous longest chain, means maximum carbon atom which is present on that chain. Then the alkyl group, this halogen atom which is considered to be a substituent on a alkyl part, means the position of the halogen may be carbon number 1, 2, 3 in this way. So number the position of halogen atom, and the position of the halogen atom is denoted by the lowest possible number, means numbering must be from that side the halogen atom that must bear a lowest possible number. So all these are the basic things, means first select the continuous longest chain, second the halogen atom which is bear a lowest possible number, means numbering should be from the lower side. For example, CH3I. So name alkyl group that contain only one carbon, means the name of the single carbon that is known as a methane. So iodomethane, iodine, iodomethane. Then in the second example, CH3CH, then CH3. So at the middle carbon there is a presence of bromine. So bromine atom which is present at the 2 position. So 2-bromo. So name of this compound is 2-bromo, and the parent chain CH3, CH and CH3 means the 3 carbon atoms, means the propane. So 2-bromo propane. Then another example, CH3, CH, CH2, CH3. So here in this compound there is a 5 carbon atoms, and the position of halogen at the 2 position. So numbering must be from the lower side. If we number from this side, then chlorine atom bears a 2 number, and if we numbering from the another side, then the position of chlorine atom is the 4. So choose the first the lowest possible number. That's why name of this compound is 2-chloropentane. Okay, another example, CH3, CH2, CH2Br. So here the common name of this compound is a N-propyl bromide. क्या? Propyl bromide. IPC name, so this compound contain a 3 carbon atoms, mean the propane. So one bromo, 1 chloro, so 1 bromo propane. Another example, CH3, CH, CH3. So here chlorine atom attached with a middle carbon atoms. Common name of this compound is the isopropyl chloride, and IPC name of this compound, the position of the chlorine is 2. So the IPC name of this compound is 2-chloropropane. Then next part, that is a physical properties of the alkyl halide. So physical properties of alkyl halide is the organic compound. So if we look the physical properties, lower alkyl halides means the lower members, for example CH3Cl, CH3Br or C2H5Cl. All these 3 compounds are the gases, means these compounds present in the gaseous form. Another all compounds which is may be present at the liquid or may be present in the solid form. Okay, so the lower alkyl halides are the gases and higher alkyl halides are the liquids or the solids. Haloalkanes have the considerably higher boiling points. If we compare the boiling point of the haloalkanes with another molecules, so haloalkanes have a higher boiling points. Why haloalkanes have a higher boiling point? So boiling point which is depends upon the intermolecular forces. So forces are 2 types of forces, for example hydrogen bonding forces, or the another is the van der Waals forces. But in this case, in the halogen, density of the halogen atoms are more. That's why boiling point of the halogen atom, haloalkanes are also more if we compare with a alkane or alkene or alkynes. So alkyl halides have a higher boiling points because in addition to the van der Waals forces, there is another property, that is a density. Density of a halogen atoms are more. That's why boiling point is also more. If we, for example, in case of the N-propane, boiling point of the N-propane is 36 degrees Celsius, while N-pentyl chloride boiling point is 108 degrees Celsius. So boiling point of the N-pentyl chloride is very high because the chlorine having a higher density as compared to the carbon or hydrogen. So boiling point, which is depends, not only depends upon the intermolecular forces but also depends upon the density of the molecule. The boiling point of the alkyl halide increases with increase in atomic weight. If we consider the in the series, means for example ethyl chloride, ethyl bromide, ethyl iodide, density in the periodic table which is increases from top to bottom, means the iodine is the heavier element as compared to the bromine, or bromine is the heavier element as compared to the chlorine. That's why boiling point also increases from top to bottom. So ethyl chloride boiling point 12.2 degrees Celsius, while ethyl bromide boiling point 38.4 degrees Celsius, while in case of ethyl iodide boiling point 72.3 degrees Celsius, means boiling point which is depends upon the density. So heavier atom attached with a alkyl group, that having a higher boiling point. Another property, boiling points of a alkyl halide is increases with increasing number of carbon atoms. We know if the carbon atom increases, then van der Waals forces increases. Area of van der Waals forces increases, then boiling point also increases. For example, N-propyl bromide boiling point is 47 degrees Celsius, while N-butyl chloride boiling point 78.5 degrees Celsius, while in case of N-pentyl chloride boiling point 108 degrees Celsius. Why? Means if we increase the carbon number, then boiling point increases near about 20 to 30 degree per added carbon. So this is the common property. If the carbon atoms increases, then boiling point increases. Another property, that is a branching. Branching increases, boiling point decreases. So in case of hydrocarbons also branching increases, boiling point decreases. In case of alkyl halides, again boiling point decreases if the branching increases in the molecule. For example, N-butyl bromide. So this is the straight chain molecule, boiling point 102 degrees Celsius, mean 102 degrees Celsius. While in case of the isobutyl bromide, means branching compound, molecular formula is same, molecular weight is same, but in the second compound there is a branching. So because of a branching, there is a spherical shape, and because of a spherical shape, area of attraction, that is decreases, means van der Waals forces decreases. That's why boiling point also decreases. Solubility, alkyl halides are soluble in the organic solvent, while alkyl halides are insoluble in the water. So solubility of the alkyl halides are insoluble in water and soluble in the organic solvents like benzene, ether, chloroform, etc. Then next point, that is a preparation of the alkyl halides. So alkyl halides which is prepared by using a different reactions. Alkyl halides may be prepared by using a carbon-carbon double bond. Alkyl halides may be prepared by using a substitution reaction. So alkyl halides prepared by using a alcohols from the alcohols. So alcohol means ROH. So OH group which is replaced by the halogen atom. So alcohols reacts with different types of the reagents, means the alkyl halides which is synthesized from the alcohol by using a different types of the reagents. For example, phosphorus in presence of halogen, means phosphorus chlorine, phosphorus bromine, phosphorus iodine, means phosphorus in presence of the halogen, then the alcohols easily convert into the alkyl halides. Or the another reagent, phosphorus PCl5, PCl3, all these are also reagents, convert alcohols into the alkyl halides. Another reagent, most important reagent, that is a thionyl chloride or the POCl3, phosphorus oxychloride. So that is also easily convert alcohols into the corresponding alkyl halides. For example, here the reactions with a halogen halides, means HX. So HCl is the acid an alcohol that having a OH group. So in the first step there is a protonation takes place. OH group, that is a bad leaving group, that convert into the OH2 positive in presence of a H plus ion. So good leaving group which is easily replaced by the chlorine. Means in the first step there is a formation of a bad leaving group that convert into the good leaving group. Means the first step is the protonation of the OH group, and then second step is the substitution. So Cl minus easily replace H2O, then convert into ethyl chloralcohol, convert into the ethyl chloride, or N-propyl alcohol that convert into the N-propyl bromide. Means in the first step there is a protonation. Then reaction with a phosphorus halides. So phosphorus halides means phosphorus in presence of the halogen, or PCl5 or PCl3 or a POCl3, all these reagents containing a phosphorus atom. So alkyl alcohols easily reacts with PCl5, POCl3, SOCl2 and easily convert into the corresponding alkyl halides. So this is the one of the good method for the synthesis of alkyl halides. Then second method from the alkenes or from the alkynes, means the addition reaction. Carbon-carbon double bond, when add the HX, means the halogen acids, then gives the corresponding alkyl halides. The halogen acids that reacts with carbon-carbon double bond and gives the corresponding acid. For example, symmetrical alkenes when react with a alkyl halogen acids, then we get the same compound. For example, ethylene that reacts with HBr gives the ethyl bromide, means the Br minus may be add first carbon or second carbon, then we get a same compound. In case of the N-butene, 2-butene, then again we get the same compound, 2-bromobutane. But in case of unsymmetrical alkenes, unsymmetrical alkene react with halogen acids and gives the two products. So here if the starting compound is unsymmetrical and the reagent, that is HX, which is also unsymmetrical, means unsymmetrical, then addition gives a two types of the product. So addition according to Markovnikov's rule. So here the carbon-carbon double bond that reacts with a HX according to the Markovnikov's rule. What is meant by Markovnikov's rule? So Markovnikov's rule is nothing but the HX or negative part of the reagent that add the olefin contain or the carbon-carbon double bond contain a less number of hydrogen atoms. Means the negative part must be add on that carbon that contain a less number of hydrogen atoms. For example, CH3 CH double bond CH2. So in this double bond, the one carbon attached with one hydrogen and another carbon attached with two hydrogen, means number of hydrogen atoms which is less in the carbon number 2. So halogen which is add at the carbon number 2. So that product is major product. That's why a 2-bromopropane is the major product while 1-bromopropane is the minor product. So why this is possible? Because here the first step is the protonation, means in the first step there is formation of a carbocation and the carbocation is more stable, secondary carbocation is more stable. That's why the halogen which is attached to the carbon number 2. Okay, means this reaction follow through the in carbocation intermediate. So in the intermediate step there is formation of a more stable carbocation. That's why a more substituted alkane, substituted or from the both side, if there is a more alkyl group, that is a major product. And in same reaction in presence of the peroxide, in presence of peroxide addition takes place opposite to the Markovnikov's rule. Means in presence of the peroxide reaction mechanism is different. In absence of the peroxide reaction mechanism is in the intermediate step there is a formation of carbocation, but in presence of the peroxide the reaction mechanism is different, means this reaction follow through the free radical mechanism, and that's why product is also different. In presence of the peroxide the propylene that reacts with HBr in presence of peroxide. So here first formation of a free radical, and that free radical reacts with the carbon-carbon double bond, and then there is formation of a more stable free radical. And if we look the stability of the free radical, primary less stable than the secondary, secondary again less stable than the tertiary, means tertiary free radical which is more stable. That's why in this reaction the halogen atom which is attached to the carbon containing more number of hydrogen atoms. So here opposite addition takes place. So this is also known as a anti-Markovnikov's rule. So addition of the halogen in the carbon-carbon double bond takes place opposite to the Markovnikov's rule. So student, in this must be solve following questions. So what are alkyl halides? Give the general formula of alkyl halide. So what is meant by alkyl halide? Alkyl halides means the halogen derivatives of the alkane, and the general formula are X. What are alkyl halides? Give the classification of alkyl halides. So alkyl halides classify by using two methods. First method is the halogen atom, number of halogen atoms attached to the carbon, number of halogen atoms attached to the hydrocarbon, and the second method which depends upon the nature of the R group. And the last question, that is give the laboratory preparation or the laboratory preparation of the alkyl halides. So alkyl halides which is synthesized by using a different route. First route is the substitution reaction, so alcohols easily convert into the alkyl halide, and another method, that is a carbon-carbon double bond, that convert into the alkyl halides. Okay, so today we stop here. Thank you very much.